The last thing we need to mention regarding the transformations of a graph is that sometimes when we transform a graph, nothing changes. If that happens to any figure, we call it symmetric under whatever transformation just didn't change anything. For the functions that we're familiar with, we're only going to see two different kinds of symmetry. We'll see a symmetry under reflection across the y-axis. That is, we'll see that when we take the opposite of each x-coordinate, the y-coordinates stay the same, in which case we call the function even. We'll also see symmetry in that rotation that we met around the origin. And what that says is, if we take the opposite of the input, it automatically also takes the opposite of the output. In that case, we call the function odd. And the reason we see that has to do with polynomials. An even power of a variable has that even property. Negative x squared and positive x squared are the same. An odd power of a variable has that odd property. If we take an odd power of negative x, that's the same as taking an odd power of x and then making it negative. You might wonder why we don't have symmetry across the x-axis. If something were symmetric across the x-axis, then negative f of x would be the same as f of x. The only number that's the same as its negative is 0. And the function f of x equals 0 is just a really boring function. Since it's the only function that does that, we don't really need a term for the category of all functions that do that. There's only the one. So here we have three functions that we want to classify as odd, even, or neither one. So the first thing we'll check is it even? To see is it even, we'll take f of negative x, and then just simplify that and see what happens. So f of negative x, that'll be negative x to the fourth power, minus 3 times negative x squared, plus the absolute value of negative x. Well, when we take something to the fourth power, that loses the sign information. So the fourth power of negative x is the same as the fourth power of x. When we square something, same deal. The second power of negative x is the same as the second power of x. And when we take the absolute value, losing the sign information is the whole point there. So the absolute value of negative x is the same as the absolute value of x. And now we look, and we see that this is the same as f. In other words, we see that f of negative x is equal to f of x, and so our function is even. That's what we call a function that does that. Okay. In this next example, we're again going to ask, is it even? We'll take f of negative x, and that'll be negative x to the third plus 6 times negative x plus the third root of negative x. Well, negative x to the third, when we take an odd power of something negative, that's the opposite of if we'd had the positive version. So this is negative x to the third. 6 times negative x, we can multiply the negative 1 times the 6, so that's just negative 6x. And then the third root of negative x, just like the third power, if we take the third root of something negative, that's the opposite of the third root of the positive version. So that'll be negative third root of x. And the first thing we notice is looking at that, that's not equal to f. So this function is not even. So our next question is it odd? To answer that, we take the opposite of f of x and compare it to what we just found. So when we're taking the opposite of something with addition in it, we just distribute that negative sign, and we see that these are the same. We see that f of negative x is equal to negative f of x, and so this function is odd. Okay, and then in this last example, we try, is it even? We take f of negative x is negative x squared minus 4 times negative x plus 3. Well, negative x squared is the same as positive x squared. So we have a positive x squared. Negative 4 times negative x, that's positive 4x. And then 3 is 3. So let's see. That's different from f because the 4 is positive here and negative here. So that's different from f. The function is not even. Our next step is to say, is it odd? If we take negative f of x, that'll be negative x squared minus 4x plus 3. Distribute the negative sign. That's negative x squared plus 4x minus 3. And we see that these two are different. Our f of negative x doesn't equal negative f of x either. So f of x is not even or odd. We could say f has neither kind of symmetry. So to see if it's even, just find f of negative x, see if that changes anything. To see if it's odd, find f of negative x, find the opposite of f of x, see if those are the same. And then if neither one of those works, it's neither even nor odd.